Chapter 13, Sample Problem Number 9. A mass spring system consists of a spring with a spring constant or stiffness K and an unstretched length L connected to a cart of mass M resting on a horizontal frictionless surface as shown. If the cart is pulled to one side a small distance and released, it will oscillate back and forth with amplitude A and frequency F. Identify from the choices below how each change will affect the frequency of the oscillating mass system. So if we increase the frequency, if we increase the mass, what happens to the frequency? And we're going to fall back on that the period for simple harmonic motion is 2 pi root m over k. So increasing m increases t. M up means t goes up, and that means the frequency goes down. So the frequency will decrease. On the other hand, we can see from our formula that if we increase k, then the period goes down, so the frequency goes up. So that would be 1 from the choices. If the mass is pulled a little bit further and released, we're increasing a, and we can see that there is no role for a. So it makes no change, and therefore this would be 3. If we have the spring constant and we have, if we double the spring constant and we have the mass, well, doubling the spring constant pushes t up. Right, t gets larger. Sorry, that's pretty bad. That if we increase k, then we decrease t. If we decrease m, then we also decrease t. So t is getting smaller, so the frequency is getting higher, which would be option 1. And then if the amplitude is increased and the mass is increased, well, it doesn't really matter what happens to the amplitude. That's not relevant. And we know if the mass is increased, we already said this would be case 2.